Hello everyone, welcome to StudyIQ. So this is a part 2 of our video series, okay? As I told you in the previous video, I'm going to discuss the divisibility rules here because when we are going to discuss about the other two concepts in reminders like Fermat theorem and Chinese remainder theorem, you need to use divisibility rules, okay? So I'll be covering the divisibility rules extensively here. When I say extensively means I'll be taking you to a very higher level where you can solve any questions which is based on divisibility. Okay, it's not at the level of SSC or IBPS or anything. You are going to solve questions at very higher level. Okay, so we will be talking about divisibility of 17, which used to come as a pattern. Then you will see divisibility of 37. Etc. special cases. Apart from that, I will complete the divisibility up to 16. That's what generally everyone do. Okay, then we will see some interesting patterns in divisibility. Okay, and then we will start making questions on the basis of the rules that you are going to learn. Okay, so this is going to be a very simple session, and I promise you after the session you will be at a much higher level. Now in the previous video we have seen the basic remainder theorem, right? When you can factorize the numerator, let's take 37 into 38 into 39 divided by 6. Okay, the actual remainder in this case, if you need to find the remainder, the actual remainder in this case is the product of individual remainders. So you will find this individual remainder. 37 by 6, easy, right? 1. 38 by 6, that is 2. 39 by 6, that is 3, right? So when you see the product, you will get 6. What does this mean? You are getting the divisor. You are getting the divisor as the product of individual remainder means this given numerator is divisible by 6 and there is no remainder. Okay, so further you can divide by 6, so obviously you will get remainder is equal to 0. I hope you understood this. Now instead of factorizing numerator, if you are getting a numerator as sum of some numbers like sum of 3 numbers or sum of 4 numbers, here you got as product of numbers. That's why we are saying factorized. Okay, numerator is factorized. So instead of product of 3 numbers, if you were getting sum of 3 numbers, let's take the same example but just put plus instead of multiplication, right? So 37 plus 38 plus 39. Okay, now divided by 6. Here also what you need to do is you can take the individual remainders and the actual remainder will be the sum of individual remainders. Okay, so you see the remainder in this case 1 plus 2 plus 3 like this and like this. Okay, now what is the actual remainder? Earlier you have taken the product, now you are going to take the sum of individual remainders, so you are getting 6. Then the balance, the rest of the rules is same in both cases. If you are getting a number which is less than the divisor, you will take that as a remainder. If you are going to get a number which is equal to the divisor, there is no remainder, that means 0 is the remainder. That is the case here. Okay, you got the number when you're finding the product of individual remainders, you got a number which is equal to divisor, that means no remainder, 0 is the remainder. Now if you are getting a number which is greater than the divisor, you further divide it with the divisor. For example, if you have 37 plus 38 plus 39 plus 40 divided by 6. Okay, so if you observe numerator, you have written as sum of 4 numbers. Okay, so you can write it as 1 plus 2 plus 3 plus 4, that is nothing but 10, right? So which is greater than the divisor, so you divide it again, you can write it as 4. Now what if it is given as product? You will write it as 37 into 38 into 39 into 40 divided by 6. What you will do? You need to find the remainder. Okay, what you will do? You will write it as 1 into 2 into 3 into 4. So here if you see, you are taking the sum of individual remainders. Here you are going to take the product of individual remainders. So 2 into 3, 6, 6 into 4, 24. So 24 is greater than the divisor, so you divide further with 6, you get 0. That means when you multiply this 4 numbers and when you divide with 6, you are going to get 0 remainder. But when you add, you will get remainder 4. Okay, you will get remainder 4. I hope this is clear for all of you. See, you will be getting questions based on the product of individual reminders. Nobody is going to ask you questions on the basis of sum of individual reminders, okay? Because the question cannot be difficult when you take sum of individual reminders. You can see in this case, if you take, why you will not get is because 36 plus 37 plus 38 divided by 6, okay? There is no need to write as sum of three numbers. It's actually a small number, okay? When you are representing a sum, still it will not be a bigger number. But when you write 36 into 37 into 38, the numerator is a bigger number. But here, this is not a bigger number. So there is not much scope of making question. So actually, what is this number? So this 2 is 72, and again 36, 108. Then add 2, 110, add 1, 111. So this number is actually 111. 108 plus 3, right? 3 is the remainder. You are adding with the multiple of 36. So 111 is the number. See, rather than even 111, you can divide easily with 6, right? So you will not get questions like this, but you can expect question like this. Now, why I discussed this is because we can use this to prove some of the divisibility rules. If you want to prove, anyway, I will not recommend you to prove any divisibility rules because proof is not required in any aptitude exam. Okay, that time is over. But to convince you, you already know the divisibility rules. I'll solve or I'll make you understand some of the proofs. Why the divisibility of 3 is because of sum of digits. Why the divisibility of 9 is sum of digits, etc. Why it is like that. If you want to know, I will prove it with the help of this concept. Okay, that's the objective of this discussion. Otherwise, you are not going to get questions on the basis of, sum of numbers as the numerator. There is a rare possibility. But product of numbers in the numerator, there is a high probability you'll get questions. So, let's start off with divisibility. Now, you will get questions like this. A raised to x. Let's take any number, okay? Or b raised to x, c raised to x. Any number. It can be 2 raised to 10, 5 raised to 10 or whatever it is. Just take a number, okay? It can be a bigger number, smaller number or whatever be the number, okay? Divide by 9. What is the remainder? Okay, so in this case, if you know the divisibility of 9, you can solve it faster. If you know the divisibility rule of 9, you can solve it faster. So if it is 99, what you will do is, you will factorize the denominator like 11 into 9. Then, if you know the divisibility of 11, if you know the divisibility of 9, you will be able to solve it faster. But this is a very higher level question. I'll teach you this question also towards the end of this discussion, and that is optional. If you are not planning to take a higher level aptitude exam, you don't want to attend that video session, because there I am going to discuss with you the Chinese remainder theorem when you are factorizing the denominator. But still the concept is same. One extra concept that you are going to learn is the Chinese remainder theorem, and you don't want to know the theorem and all. We will see the shortcuts and we will solve it faster. Okay, so let's start off with divisibility. So I hope you might have understood the use of divisibility. You get questions like 7, 7, 8, 9, 3, 9, 4, 1, 2 divided by 13. What is the remainder? If you just get a question like this is a random question, right? You can easily find the remainder when divided by 13 by manually dividing. But the problem is you may take some time. To avoid that time consumption, what you can do is, if you know the divisibility rule of 13, you can do it faster. Okay, in 10 seconds you can get the answer if you know the divisibility rule of 13, but you may take 1 or 2 minutes if you need to do it manually. So that is the objective of this discussion. So I hope you might have understood why I am discussing this divisibility rule. Okay, now sometimes you may not get questions directly like this. You need to apply divisibility rule in one part of the question. So that part itself you will consume a lot of time if you don't know the divisibility rule. Okay, I hope this is clear for you. So let's start off with divisibility rule. Let's start with the small numbers, then we will move on to the higher numbers. Okay, so all of you know the divisibility rule of 2. Okay, divisibility rule of 2, the number should be an even number. Okay, so the number should be an even number. So basically this is based on the last digit. So divisibility rule of 2 is based on last digit. Last digit must be an even number. Okay, so last digit must be an even number. So if you generalize, all 2n numbers are divisible by 2. What are 2n numbers? That is even numbers. So why it is divisible by 2 if you ask me? There is a 2. That's why it is divisible by 2. I hope this is clear for all of you. Okay, so there is nothing to discuss in divisibility of 2. Now let's move on to divisibility of 3. Okay, divisibility of 3. So what is the divisibility of 3? You will tell me directly that it is sum of digits. Okay, so if you have a question 1 to 4, okay, divided by 3, what is the remainder? If I ask you, what you will do? You will find sum of digits 1 plus 2, 3, 3 plus 4, 7. Now 7 you will divide by 3 and you will get remainder 1. So you will directly tell me that this number is not divisible by 3. In case if you divide, you get remainder 1. That is the idea of this, right? But why it is sum of digits? I hope most of you don't know why it is sum of digits, but you can easily understand why it is sum of digits from the previous discussion that we have done. Okay, so any digit number you take, let's take a 3-digit number 1, 2, 3. Okay, 1, 2, 3. So how will you write this 1, 2, 3 in the standard format? All of you know this is ones place and this is tens place and this is hundreds place, right? So the standard format is 1 into 100 plus 2 into 10 plus 3 into 10 raised to 0, that is 1 if you want. Okay, so actually 1 into 10 square plus 2 into 10 into 3 into 10 raised to 0 if you want. Okay, so I hope this is clear for all of you. All of you know this, right? So what you did now is basically you are writing 1, 2, 3 as sum of 3 numbers, right? What is that? This is 100, this is 20, this is 3. Now if you divide this with 3, as per our rule, okay, you can take individual remainders and the actual remainder will be sum of the individual remainder, right? So you can take individual remainders like this, you can take like this, you can take like this, then actual remainder will be the sum. Now to find individual remainder, I give you another easy method. Okay, see, if you divide 10 with 3, what is the remainder? 10 by 3 is 1. Okay, 10 by 3 is 1. If you divide next power of 10, that is 10 square, that is 100. 100 by 3, what is the remainder? Remainder is 1 because 99 is a multiple of 3, remainder is 1. Now, if you divide 1000 by 3, that is the next multiple of 3. That is the next multiple of 10, 10 raised to 3. You will get again remainder 1. Why? Because 999 is a multiple. If that is the case, 10 raised to 4 is also 10 raised to 4 divided by 3 is also 1 because 9999 is a multiple of 3. 10 raised to 5 divided by 3 is also remainder 1. So for that matter, any power of 10 if you take, you divide by 3, you will get remainder 1. So that means the idea is, why I am telling this is because if you get any number, any bigger number, let's take 1, 2, 3, 4, 5. How will you represent this as a standard form? This is 10 raised to 0, this is 10 raised to 1, this is 10 raised to 2, 10 raised to 3, 10 raised to 4, right? So 1 into 10 raised to 4 plus 2 into 10 raised to 3 plus 3 into 10 square plus 4 into 10 plus 5 into 10 raised to 0. Okay, so that's the number. Now in this, if you divide this 10 raised to 4 with 3, you get remainder 1. This 10 raised to 3 with 3, you get remainder 1. 10 square with 3, you get remainder 1. 10 with 3, you get remainder 1. So in all those cases, you get remainder 1. Now, let's take this part alone, 3 into 10 square. So can you tell me what will be the remainder in that case? Or you take this part alone, okay, 2 into 10 cube by 3. So I am taking 2 into 10 cube divided by 3. Can you tell me the remainder in that case? I know 10 cube by 3, I will get remainder 1. Then 2 by 3, what is the remainder? 2. So the actual remainder will be the product of individual remainders, 1 into 2, so that is 2. Okay, so if you observe here, the digit is 2, remainder is 2 when you take that place only. So here the remainder will be 3. 3 means actually 0 remainder. Now 4, 5. So 4 is greater than the divisor, so you will divide it with the 3 again, you will get 1 as the remainder. So now let me conclude. 1, 2, 3. Why I am writing sum of digits as the divisibility rule of 3 is basically because I know 10 raised to any power will give me, when you divide with 3, will give me remainder 1. Okay, 10 raised to any power divide by 3 will give me remainder 1. So any number if you take 5 into 5, 6, 7. I have this number, I am just taking a random number 5, 6, 7. So I can write it as 5 into 10 square plus 6 into 10 plus 7. Okay, now divided by 3. Okay, now divided by 3 means I can divide individual terms like this and like this, right? And see the individual remainders. Okay, so let me take the first one. What is that? 5 into 10 square by 3. This is written as product of 2. Here also I need to use the basic remainder theorem. So I know I can divide like this, I can divide like this. So if I divide 5 by 3, I get remainder 2. Okay, and if I divide 10 square by 3, I get remainder 1. So this is actually 2. Remainder is 2. Now even if I just write this 5 alone, I get remainder 2 because 5 is greater than 3, so I need to divide it with 3, remainder 2. Okay. Now, so what is going to happen? If you take this one, what will be the remainder? Remainder is 6, and still you need to divide 6 with 3. Then you actually get remainder 0. But I can consider 6 as the remainder. I hope you understood this because 10 by 3 is remainder 1. So 6 into 1 is the actual remainder in that case. So 6 into 1 means 6. But 6 is greater than 3, so 6 divided by 3. Okay. So that is the reason why you are taking sum of digits. You can take 5 plus 6 plus 7. Why? Because 5 is the remainder here, 6 is the remainder here, 7 is the remainder here. Then when you take sum, you get 11 plus 7, which is 18, which is greater than 3. So you further divide with 3, you get remainder 0. Okay. So that is why you take sum of digits. Now otherwise, if you find 5 divided by 3, you can do, you will get 2. 6 divided by 3, what is the remainder? 0. So plus 0. 7 divided by 3, what is the remainder? 1. So what is total? 3. Now this 3 you can divide with 3, still you get remainder 0. So that's what we have done here. We are not doing at this stage. We are just taking sum of digits and we are dividing with 3. I hope you understood this completely. But anyway, this is not required for you. Just understand the divisibility rule of 3 is based on sum of digits. If sum of digits is divisible by 3, that number is divisible by 3. Now what is the divisibility of 4? Divisibility of 4 is actually last 2 digits. Last 2 digits. You need to check for the last 2 digits whether the last 2 digits is divisible by 4 or not. So if you have a number 1, 2, 3, 8, 7, 6, 2, 4, you need to divide by 4 and you need to see the remainder. Rather than dividing the bigger number which is there in the numerator with 4, you can just take the 2 digits, you can divide that by 4, see what is the remainder. Same will be the remainder if you divide the bigger number with 4. So why I waste my time by dividing the bigger number with 4? This will be useful in a lot of examples. We are going to discuss many questions after these concept building sessions. Okay, so you will realize it soon. So 24 divided by 4, 0. So that means answer for this question is 0. But if I give you one more number, 7, 8, 6, 7, 4, 4, 3, 2, 1, 7 divided by 4, what is the remainder? What I'll do, I'll just take the last 2 digits and divide by 4. 1 is the remainder. Now divisibility of 5, all of you know, right? This is last digit. Okay, what is the condition? Last digit should be either 0 or 5. Last digit should be either 0 or 5. So if you get a question like 1, 2, 3, 7, 8, 7 divided by 5, what is the remainder? What is the answer? You see whether it is 0 or 5. If the last digit, it depends on last digit, just look for the last digit. Last digit is 7, you divide 7 by 5, write the remainder 2. Okay, similarly, if the question is 7, 8, 6, 7, 4, 3, 2, 1, 3 divided by 5, what is the remainder? Anyway, 25, 35, etc. we will cover in the coming sessions, but here you understand 5. Okay, so what you will do, just take out the last digit, 3 divided by 5, what is the remainder? 3. You cannot divide 3 with 5. Now if this is coming as a part of a question, then instead of 3 you can take minus 2 as the remainder to make the calculation easier. That concept we have already discussed in the previous video session. Now divisibility of 6. What is the divisibility of 6? It is actually 2 into 3. The condition is the number must be divisible by 2 and it must be divisible by 3. Okay, so you know the divisibility of 2, it should be an even number. Divisibility of 3, sum of digits must be divisible by 3. So if both conditions are satisfied, the number is divisible by 6. 1, 2, 3, is it divisible by 6? No, because it's an odd number. So you don't want to check for the other. What about 1, 2, 6? First you need to check whether it is a even number. Yes, it is an even number. Then you check sum of digits. 1 plus 2, 3, 3 plus 6, 9. 9 is divisible by 3. So two conditions satisfied. So 1, 2, 6 is divisible by 6. Now the typical aptitude questions that you can get is 1, 2, 3, 4, 5, 6, 7. Okay, you have a number. They will ask you what is the next multiple of 6. Okay, so this is a number A is given. What is the next multiple of 6? So here you will use the divisibility rule of 6 only. What is the divisibility rule of 6? Next multiple of 6 means it is obviously an even number. Okay, so you can just put this as 8 and check. What if it was 8? It's an even number. Now what do you need to check? Let's check the sum of digits. Okay, what is sum of digits of this numbers? These are consecutive natural numbers. So sigma n, I hope you know this. Anyway, I will be discussing this sigma n concept later. So sigma n is n into n plus 1 by 2. Very important in the coming sessions. We'll discuss more. So here 7 into 8 divided by 2, that is 28. Okay, so sum is 28. For this number, sum is 28. So if sum is 30, it is divisible, right? If this 28 is 30, this number is divisible by 3. So how will you make it 30? You can put this as 9. Instead of 7, if you change it to 9, the sum you will get as 30. Then it is divisible by 3. But what is the problem? It's an odd number. That means it is not divisible by 2. So if you need to get a number which is a multiple of 2 and 3, add 3 more. Because you understood that 1, 2, 3, 4, 5, 6, 9 is a multiple of 3. But the problem is it's not a multiple of 2. So add 3, you get another multiple of 3, it becomes an even number also. Then add 3 means 1, 2, 3, 4, 5, 7, 2. So if the question is about what is the next multiple of 6, your answer is this. Why? It's an even number. The sum of digits is divisible by 3. So both conditions satisfied. What if the question was previous multiple of 6? Then your answer is 1, 2, 3, 4, 5, 6, 6. See, it's an even number in the end. At the same time, sum of digits if you take, you get 3. Or multiple of 3. Or sum of digits you can divide with 3. So previous multiple is this, next multiple of this. These are the two questions which is possible. Or they will ask you what is the remainder in this case. That is a easiest question. Right? Remainder is 1. Next is divisibility of 8. Okay. See, 7, 11, 13, 17, 37. I will cover separately in divisibility part 2. Okay. So I will do the divisibility again in 2 parts. So this I will cover in part 2. So now I will discuss about 8, 9, 10. Okay. Then 12, 14, 15, 16. Then we will see some patterns. Then after that, these are some important patterns which you can get in exam. The questions looks difficult, but you can solve faster by applying the method. Okay, so I'll cover 7, 11, 13, 17, 37 together. The reason is almost the same method is what we are going to use in all these 5. Okay, and I have seen the 17 and 37 in previous CAT papers also. Okay, so this level of questions you can get in SSC, IBPS, etc. This I have seen in CAT. But anyway, we will cover everything together. Okay, the method is same. The difficulty level is also for same in case if you are using our method. So it can't be difficult for you anyway. Okay, so divisibility of 8, last 3 digits. Okay, last 3 digits. See, if you see in case of 2, you have seen last digit, okay, or 1 digit only. Then 4, you have seen last 2 digits. I'm not going to prove why it is, okay, so it is not required. I will be taking a lot of time. So you have already seen in case of 3, I've taken some time, 10 minutes or something to prove it, okay. It's actually not required for you. I can prove it easily, but still it is not required for you, okay. So why? Because this is 2 raised to 2, this is 2 raised to 1, this is 2 raised to 3. So this is 2 raised to 3, last 3 digits. 2 raised to 1, last digit. 2 raised to 2, last 2 digits. Okay, so you can tell me 16 directly because 16 is 2 raised to 4. So obviously last 4 digits. Now what do you mean by last 3 digit, last 4 digit, last 2 digits, etc.? If you get a number 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 0 divided by 8, what is the remainder if is the question? Rather than dividing the bigger number which is there in the numerator with 8, you can just take out this 900 and you can divide. Okay, so what is the remainder? See, you don't want to do also like in the first second you understood that the last 3 digits is what required. You know 800 is a multiple of 8, right? 888 is also a multiple of 8. So in the first second, what come to your mind is 800. Then second, 888. Then you add 8 more, you get 896. So 896 you can divide with 8 completely. So what is the remainder? Here it is 900. So remainder will be, what will be the remainder? Remainder will be 4. Now when you divide 900 by 8, you will get remainder 4. Same will be the remainder if you divide this bigger number by 8. Okay, 9 I have already discussed with you sum of digits, right? So you learned this as sum of digits, similar to 3. So sum of digits must be divisible by 9. Okay, so if you have a number 1, 2, 3, you take sum of digits, you get 6. It is not divisible by 9, so 1, 2, 3 is not divisible by 9. So what if you have 1, 2, 6, you take sum of digits, you get 9. That is divisible by 9. So this 1, 2, 6 is divisible by 9. That is idea. Okay, so if you take 3, 2, 7, 4. Okay, so 3, 2, 5, 5 plus 7, 12, 12 plus 4, 16. So what you got is 16. Okay, you need to check whether the sum was divisible by 9. No, that means this number is not divisible by 9. Now, if your question was 3274 divided by 9, see what is the remainder. Okay, this was the question. So, as per your understanding, you will take sum of digits, you get 16. You divide by 9, you get remainder as 7. Right? So, you get remainder as 7. But you know, 9 is a very special case. I don't know how many of you know it or not. If you need to find the remainder, what you can do is, unlike 3 where you're just getting the sum of digits, 9 also, I hope till now you might be knowing about that only. But when you take the sum of digits, if you take sum of digits till you get a single digit, that means here you got 16. You take sum of digits of 16 again, that means 1 plus 6, you get 7. So what you get is actually the remainder. Okay, see, the rule is you take sum of digits till you get a single digit. What is a single now what are the possibilities? You can get from 1, 2, 3, 4 up to 9, right? These are the 9 possibilities. 0 you won't get anyway because you are taking sum. It can't be 0. So these are the possibility. Now out of this possibility, finally if you get single digit as 9, that number is divisible by 9. That means remainder is 0. If you get any other digits among this 1, 2, 3, 4, 5, 6, 7, 8, that is the remainder when you divide the bigger number by 9. Let's take an example. 1, 2, 3, 4, 5, 6 divided by 9. You need to see the remainder. What you will do? You will take sum of digits till you get a single digit. Now 1, 2, 3, 4, 5, 6 means 6 into 7 by 2, that is 21. Sum was 21. Why 6 into 7 by 2? I did sigma n. Right? These are consecutive natural numbers. So 21. Now, till now what you used to do, 21 divided by 9, you get 3. But what I will do, I will just add this 2 and 3, 2 and 1. So I get 3. So which one is better? Take sum of digits till you get a single digit. Okay. So if you get a sum of digits as 3-digit number, then it is difficult. You may not get it, but still you can make it much more easier by bringing into sum of digits till you get a single digit. Okay. So if you have a complex number, let's take 1, 2, 3, 4, 5, 6, 7, etc., 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 up to 9 or up to 99. Okay. So this number is going on up to 99. That means 98, 99, etc. These are numbers. So if I ask you divided by 9, what is the remainder? How will you solve this? Now you cannot find sum of digits manually, right? It's not like 1, 2, 3. If it is 1, 2, 3, you can add 6 divided by 9, you can get it. But if I ask you what is the remainder in this case, you need to find the sum here, right? So how will you find? What you can do is you will take 1 at a time up to 9. Okay, 1 digit at a time. So 1, 2, 3, 4, 5, 6, 7, 8, 9. You can do it as sigma n. Okay, then basically up to 9 you can take 1 digit at a time, and after 10 up to 99 you can take 2 digit at a time. Okay, so then I am taking 10, 11, 12, 13, etc. So I add all these digits. So I am actually converting this question to a sigma n question. So I get 1 plus 2 plus 3 plus etc., etc. up to 99. That's actually sigma n. Now I know sigma n, right? So n into n plus 1 by 2. I will discuss this in detail. I have just taken an example. Now if you feel any difficulty with this topic, just leave it. Just leave this example. We will cover this example in detail in the coming session when we discuss about numbers, first chapter. Okay. So here n is 99. So 99 into 100 divided by 2. Now here, how will you divide? See, either you can get cancelled like this, but then 99 into 50 is difficult multiplication, right? So better you can do this. Take half of 99. Okay, so that is 49.5. Then multiply with 100, that is easy, right? So 49, 50. That's the sum you get. See, I hope all of you understood this, right? So just to make the calculation easier, I did this. Okay, I just took half of it. Then I multiplied with 100. That I can do easily. If you do, see, generally what you do, you will just cancel this and you'll write this as 50, then you think of 99 into 50, right? That is difficult, even more difficult. Maybe you take 1 or 2 seconds more. Okay, so this is better approach. So I got sum as 4950. Then what you do? You divide 4950 divided by 9. So this question you can solve only if you know sigma n, and also you should know the divisibility rule of 9. So now the question is converted to 4950 by 9. Even this also I don't want to divide. Okay, what I can do is I can take sum of digits again. So 4 plus 9 plus 5 plus 0. So 4 plus 9, 13. 13 plus 5, 18. Okay, so I hope this is clear for you. So what you got is 18. Still I need to get this, now also I need to take the sum of digits, right? So I am doing it till you get a single digit. So what is the single digit you got? 9. That means when you get the single digit as 9, this number is divisible by 9. So what is the remainder? Remainder is 0. Very difficult question you solved in seconds based on the divisibility rule of 9, but only thing that you need to apply here is this sigma n concept. If you don't know this, you cannot solve it. You cannot manually count anyway. So sigma n, if you have any problem, I'll discuss after some time. Sigma n. Okay, when it comes to arithmetic progression and all, we'll discuss it in detail. So divisibility rule of 9 is very interesting. Sum of digits till you get a single digit. Now forget about what you have learned till now. That is not required. Okay. If you need to check whether it is divisible by 9 or not, if you need to find the remainder, in all cases, if it is 9, take sum of digits till you get a single digit. Okay. You got a number 1750507 divided by 9. See the remainder. I can ask this question or I'll ask you whether this is divisible by 9 or not. Okay. So what I'll do? I take sum of digits 8. 8 plus 5, 13. 13 plus 7, 20. So 20, right? What I'll do now? I'll take sum of digits again. So I get 2. So last digit is 2 means 2 is the remainder. I got the answer directly. 2 is the remainder. When the 17507 divide by 9, you get 2 as the remainder. Now, they can ask you, another question. It's like this. What is the next multiple of 9 after giving this number? Okay, this number is given, 17507 is given. What will be the next multiple of 9? Okay, then what's your answer? You got the remainder 2, add 7 more. Okay, so add 7 more means 17514, right? Because you got the remainder 2. Remainder 2 means you have already 2 extra. If you have 7 more, you get a number which is divisible by 9. Or when you take sum of digits, you got 2. You should have got 9. How you make 9? You add 7. Where you add 7? You add 7 here. So you get 17514. Now if you want to, you can check it. You can take sum of digits. Okay. So 17885, 13, 13 plus 1, 14, 14 plus 4, 18. Now 18, if you take sum of digits again, you get 9. I hope this is clear for you. Now what if by giving this number, if they ask you what is the previous multiple of 9, then it is easy. You got the remainder 2, subtract the remainder. So what is the previous multiple? You will write it as 1750 subtract 2. So it will be 5. If you want, you can check. Just take sum of digits. 1 plus 7, 8. 8 plus 5, 13. 13 plus 5, 18. 18 means 9. So I hope this is clear for all of you. Now 10. Everybody know last digit. Okay, last digit must be 0. 12. 12 is actually 4 into 3. You know 4. You know 3. Divisibility of 4, last 2 digits. 3 sum of digits. Based on that, 12 you can solve. 13 I will discuss. 11 I will discuss in the next session. 14 is actually 7 into 2. So 2 you already know. 7 I will be discussing in the next session. So you'll come to know about 14 also. 15 is actually 5 into 3. 5 you know last digit must be either 0 or 5. 3 you know sum of digits. 16 I have already discussed. 2 raised to 4 is 16. So last 4 digits. Last 4 digits. So I hope all of you understood the divisibility rule of what we have discussed till now. That means except 7, 11, 13, 17, 37. Except this we have discussed up to 16.